Hello students, welcome back to our class. In the previous session we discussed a few set of examples on nth term of an AP as well as sum to n terms of an AP. Now in this module the very important exercise and the problems on multiple concepts given in optional exercise of our arithmetic progressions chapter. Let us go through those problems one by one and then you will get a clear cut idea on the problems of sum to n terms of an arithmetic progression. So, exclusively I am now explaining the problems of optional exercise. Before that we have exercise 5.1, 5.2, 5.3. 5.1 is about some sequences are given, you will have to check whether this is an arithmetic progression or not, and then if it is an arithmetic progression find the common difference as well as the first term, and then find out some next 4 terms or 5 terms of arithmetic progression. In exercise 5.2 we talk about some applications of nth term of an arithmetic progression, but in exercise 5.3 we talk about the problems on sum to n terms. So, in 5.4 optional exercise we have set of problems talks about the entire topic of arithmetic progressions. So, let us try to understand the problems. Now, exclusively we are going to do optional exercise, that is 5.4 of arithmetic progression. So, I will write that here, this is optional exercise 5.4. Okay. So, what are all the problems given? I am not going to copy those problems on the board, anyway they are available in the textbook. I will just tell them, read them, and then I will answer those problems on the board. So, please do concentrate because these are very important and interesting problems, and there are many number of real life applications are there in these problems also, right. So, coming to the very first problem is going to be which term of an AP. The very first problem is which term of the AP, according to the given problem the arithmetic progression is, what is that arithmetic progression? 121, 117, 113 and so on. So, which term is the first negative term? Okay. So, first negative term, what is the first negative term? First negative term of this arithmetic progression is equal to what? So, what is the first negative term of this arithmetic progression? For that, let us have that arithmetic progression. We can easily identify what is the first term as well as common difference, where the first term is going to be 121 and common difference is equal to A2 minus A1, which is equal to 117 minus 121 is going to be negative 4. Which term of an AP is first negative term? We do not know. So, let AN be the first negative term, AN be the first negative term. So, AN be the first negative term. So, generally what are negative numbers? So, the negative numbers are the numbers called less than 0 numbers are negative numbers. So, according to this my AN is the first negative number. So, AN less than 0. Then I will substitute the formula for AN, that is A plus n minus 1 times D less than 0, right. The value of A is going to be 121, it was given, plus n minus 1 times D is going to be negative 4, which is less than 0, right. When you simplify this, you will get to know that 121 plus into minus 4n is minus 4n and minus of minus plus 4, which is less than 0. If you simplify, 121 plus 4 is equal to 125 minus 4n less than 0. So, when you simplify this, 125 less than 4n. So, 125 less than 4n means you can write this one as 4n greater than 125. 4n greater than 125 means n greater than 125 divided by 4. Since this 4 is being a positive number, so that you can easily transpose According to the laws or properties of inequalities, you can transpose positive number towards right hand side. If it is negative number, then you will have to think when you are transposing negative number, the inequality sign will be changed when you are talking about multiplication as well as division, right. So, n greater than 125 by 4, 4 3s are 12, 4 1s are 4.25, n greater than 31.25, what does that n indicates? That n indicates the number of terms. So, the number of terms cannot be negative, cannot be fraction, cannot be decimal, right. So, n greater than 31.25 means what? From above 31, all the numbers are negative numbers only. Above 31 means what? 32nd term, 33rd term, 34th term, all these terms are negative terms only. So, therefore, n takes the values 32, 33 and so on. So, we can say that 32nd term is the first negative term. Which term is the first negative term? 32nd term. Therefore, 32nd term is first negative term, right. So, if the first negative term is 32nd term, what is that number? That number is going to be a 32, which is equal to a plus 31d. When you substitute them, the value of a is going to be 121 plus 31 into d is equal to negative 4. So, how much is this? 121 minus 124, 121 minus 124 is equal to minus 3. So, this minus 3 is the first negative number, and which term is the first negative number, first negative term, that is 32nd term is the first negative term. So, hope you understand how to answer this. These are very important problems as well as interesting problems also, right. Coming to the next problem, the next problem in this 5.4 exercise is, I am going to read it out. The problem is the sum of the third and seventh terms of an AP is 6. So, according to the given problem, the sum of third and seventh terms, sum of third term means A3 and seventh term is A7, sum of third and seventh terms of an AP is 6 and their product is 8. Their product means A3 into A7 is equal to 8. So, what are you asked? Find out the sum of first 16 terms of an AP. Sum of first 16 terms of an AP is equal to how much? This is what the problem given in the name of second problem of 5.4 exercise, right. Let us try to understand. A3 plus A7 is equal to 6. A3 plus A7 means third term plus seventh term is equal to 6. Third term is going to be A plus 2D and seventh term is going to be A plus 6D is equal to 6, right. A plus A is equal to 2A plus 2D plus 6D is equal to 8D is equal to 6. When you take 1 2 common, then it would be 2 into A 2A plus 2 into 4D is equal to 8D, 2 into 3 is equal to 6. So, A plus 4D is equal to 3, then the value of A is going to be 3 minus 4D. This way I can get the value of A in terms of D from the first information. And what is the second information given here? Second information given as third term into seventh term is equal to 8. Third term multiplied by seventh term is equal to 8. What is the formula for third term? Again A plus 2D multiplied by A plus seventh term is 6D is equal to 8. But we know the value of A is equal to 3 minus 4D, right. Let us substitute A is equal to 3 minus 4D here. Then it would be A is 3 minus 4D and plus 2D is already there. So, plus 2D times A is again 3 minus 4D plus 6D is equal to 8. When you simplify, 3 minus 4D plus 2D is going to be minus 2D multiplied by 3 minus 4D plus 6D is plus 2D is equal to 8. Once you see here, this is in the form of A minus B into A plus B. So, A minus B into A plus B is going to be A square minus B square. A is equal to 3, 3 square is equal to 9 minus 2d whole square. 2d whole square is equal to 4d square is equal to 8. So, transpose 4d square towards right hand side and 8 towards left hand side, then it would become 9 minus 8 is equal to 1 is equal to 4d square. So, 1 is equal to 4d square, you can write it as d square is equal to 1 divided by 4. Then what is the value of d? D is equal to plus or minus square root 1 by 4. Plus or minus square root 1 by 4 means plus or minus square root 1 is 1, square root 4 equal to 2. Therefore, the value of d is going to be plus or minus 1 divided by 2. See, we got the value of d. But here two values of d. Since two values of d's are there, then you will get two values of a's. So, with the help of one particular pair of a and d, we can find sum of first 16 terms. With the another pair of a and d, we will get sum of first 16 terms of arithmetic progression. So, there are two different cases that you will have to notice, right. Okay. Let me take first d is equal to positive value. Okay. So, the value of d is equal to, if the value of d is equal to positive 1 by 2, then what about a here? A is equal to, there is a formula for a in terms of d, that is 3 minus 4d. So, 3 minus 4 into d is going to be 1 by 2. Okay. 2 gets 2 1s, 2 2s are 4, 3 minus 2 is equal to, what is the value of 3 minus 2? Is equal to 1. Therefore, the value of d is equal to 1 by 2, a is equal to 1. With the help of this a and d, you can find sum of first 16 terms. So, therefore, sum of first 16 terms is equal to 16 by 2 times 2a plus n minus 1 into d. 2a, a is equal to how much? It is 1. So, 2 into 1 plus n minus 1 means 16 minus 1 into d is going to be 1 by 2. So, hope you understand this substitution. We substituted the values of a, d, n in the formula for Sn is equal to n by 2 into 2a plus n minus 1 into d, because you are going to find sum of first 16 terms. So, here in this case n is going to be 16. So, when you simplify this, 16 by 2 is equal to 8 times 2 into 1 is equal to 2 plus 16 minus 1 equal to 15 divided by 2. Got it? So, which is equal to 8 into 2 plus 15 by 2, 2 2s are 4, 4 plus 15 is equal to 19 divided by 2. So, 2 1s, 2 2s are 4, then the value of S16 in this particular case is going to be 19 4s are how much? 76. So, this is sum of first 16 terms of arithmetic progression when the value of d is 1 by 2 and the value of a is equal to 1. But we have one more value of d there. We use d is equal to 1 by 2. Now, you have to use d is equal to negative 1 by 2, right. So, the second case is when d is equal to negative 1 by 2. If d is equal to negative 1 by 2, then what about the value of a? So, then the value of a is going to be, substitute here 3 minus 4d. So, 3 minus 4 into d is going to be negative 1 by 2. So, then the value of a is equal to 2 1s, 2 2s are 4. So, this is minus 2 into minus is equal to plus 2, 3 plus 2 is equal to 5. So, a is equal to 5, d is equal to minus 1 by 2. Therefore, sum of first 16 terms is equal to, again n going to be 16. So, 16 divided by 2 times 2a. So, 2 into 5 plus n minus 1 is 16 minus 1 into d is equal to negative 1 by 2. D is going to be negative 1 by 2. 16 by 2 is anyway 8 times 2 into 5 is equal to 10. Okay. And see, this is minus 1 by 2, right. So, minus will come here. 16 minus 1 is equal to 15. So, 15 divided by 2. So, when you simplify this, it is going to be 8 times 2 10s are 20 minus 15 is equal to 5 by 2. So, 2 1s, 2 4s are 8, 4 5s are 20 is the sum of first 16 terms of this arithmetic progression. So, this way we can easily figure out what is the sum of first 16 terms of an arithmetic progression when third term plus seventh term is given 6, as well as their product is given as 8. So, hope you understand. So, this is what the way of answering the problem. Coming to the third problem, the third problem is going to be third problem of our optional exercise 5.4. Here the problem given as a ladder has rungs 25 centimeters apart. See, this is what the ladder that I am drawing. This is one ladder. In this ladder there are some rungs given. This is one rung, okay, and these are some rungs given like this. These are the rungs given. In this particular problem, what is the given information? The length of the first rung is going to be 25 centimeters and the length of the last rung is going to be 45 centimeters, okay, and the distance between these two consecutive rungs is again 25 centimeters. So, this is 25 centimeters and the distance from the first rung to the last rung is given, first rung to the last rung is given as 2.5 meters. So, this is 2.5 meters. What are you going to find? Find out the length of the wood required for the rungs. Find out the length of the wood required for the rungs. See here, you can understand this problem easily. For example, you have a ladder like this, okay. I am just taking the ladder. This is the first rung, this is second rung, this is third rung, this is fourth rung, this is fifth rung. See, if there are 5 rungs, then how many gaps are there? If there are 5 rungs, the number of gaps is equal to 4. Suppose if you know the distance between first rung to the last rung, and if you know what is the distance between two consecutive rungs, then you can easily find out the number of gaps between the rungs from first rung to the last rung. You know how it is? First gap plus second gap plus third gap plus fourth gap is going to be the total distance between the rungs. So, that the total distance between the rungs divided by the gap between two consecutive rungs will be the number of gaps. Suppose if there are 4 gaps, then there are 5 rungs. If there are 3 gaps, then there are 4 rungs. If there are 10 gaps, there are 11 rungs. So, you can easily calculate how many number of gaps are there. Did you get my point? You can find out the total number of gaps between the rungs. If you know the number of gaps added by 1 will be the number of rungs. See here in this case, we know what is the distance from the first rung to the last rung, and distance between two consecutive rungs is also given. With the help of this, we can easily find how many number of gaps are there, right. See here, according to the given problem, I am going to find the number of gaps. So, the number of gaps between the rungs is equal to distance between first and last rung divided by distance between two consecutive rungs. So, distance between first rung to the last rung is going to be 2.5 meters. So, 2.5 meters divided by distance between two consecutive rungs is equal to 25 centimeters, right. See, numerator is in meters, denominator is in centimeters. So, you will have to convert both of them into same units, anything is okay. So, 1 meter is equal to how many centimeters? 1 meter is equal to 100 centimeters. So, 2.5 meters means 2.5 is equal to 5 by 2 and 1 meter is equal to 100 centimeters whole divided by 25 centimeters. Got it? So, centimeter gets cancelled. 25 ones, 25 fours are 100, 2 ones, 2 twos are 4. Therefore, the total number of gaps is going to be 5 twos are 10. The number of gaps is equal to 10. Since the number of gaps is equal to 10, therefore, what about the number of rungs? Number of rungs is equal to number of gaps plus 1, right. So, the number of gaps is equal to 10 plus 1 is equal to 11. So, there are totally 11 rungs. What are we going to calculate here? We are going to calculate the total wood required for only the rungs, not the entire ladder, only for the rungs. Okay. So, to find out the total wood required, we can understand this concept in terms of arithmetic progression, and that too sum to n terms of arithmetic progression. You know why? We know what is the length of the first rung. Let us consider the length of the first rung is equal to first term, and we know what is the length of the last rung, that could be 45 centimeters. So, you can consider that one as nth term, and we know how many number of terms also there. The number of terms is nothing but the number of rungs is equal to 11, right. So, if you keep adding 25 centimeters and then 45 centimeters by taking a and n is equal to 11, we can easily find out what is the wood required for the total rungs. So, therefore, wood required for the rungs, wood required for the rungs is equal to sum to how many terms are there? Sum to 11 terms of AP, 11 terms of AP, in which the value of A is going to be the first rung, that is 25 centimeters, and AN is going to be 45 centimeters, and then n is going to be 11, right. We can use the formula Sn is equal to n by 2 into A plus An, where n is equal to 11. So, therefore, S11 is equal to 11 divided by 2 times A plus An, A is equal to 25 and An is equal to 45, which is equal to 11 divided by 2 into 25 plus 45 is equal to 70. So, this is 2 ones, 2 35s are 70. So, 35 into 11 is equal to 35, 385 centimeters. So, this is what the length of the wood required for the rungs.